Okay, good morning. You're on to Mama with Jarvis, and we would. This is video number, I think it should be 93, and we're hoping that we'll get to video 100 shortly. But the essence of our classes would remain to help you understand mathematics, especially if you're somebody that is very interested in doing well in maths, one, and you are ready to practice. I will say this, and I will say this repeatedly. You do not need intellect to do well in maths. All you need is interest and a willingness to practice. Having said that, we're on to grade 10 algebra, and we'll continue from where we stopped, considering the topic linear equations involving what? Fractions. We'll kick off from question 4 using our preferred reference material for this course, which is the New General Mathematics for SS1. And then we will go to page, grade 10 is called, we'll go to page 79, exercise 9, exercise 6C. I will just solve a few of the questions and see how we fare with them. So straight ahead to business. We look at question 4, and it says 3y minus 2 over 9 equal to 4/7/9. I always say, when you're given a problem, do not be in a hurry to just solve. Try to understand what the question wants you to do and search out what are the previous knowledge I've gathered that can help me solve the question. So I'll help you do that by just pointing out the things you should look out for in solving this problem. Number 1, you need to change this to improper fraction. That's number 1. Once you've done that, so let's do that and let's see what happens. This will become 3y minus 2 over 9 equal to what? 4 times 9 is 36 plus 7. That will be what? I hope I'm spot on that. So that will be 43 over 9. The next thing you want to take care of is you clear out the denominator. What is most important when you're handling any equation involving a fraction? Just as dealing with negative when you see them in equation is so important, when it comes to fraction, you must take care of the denominator. So that should be your top priority when solving questions of this magnitude. You need to deal with the denominator. As an extra note to this, I always tell students, we don't need a fine notes in mathematics. What we need is a fine solution. So you have this margin and this margin. You can do your rough work for 2 major reasons. 1, for me as the examiner, it tells me you know what you're doing. 2, for you as a student, it helps you when you're going back to revise to know what to do or to remember what you had done to solve that problem. So we'll take the LCD to be 9 because the denominators are what? 9. If I multiply through by 9, this becomes what? 3 times 3y, 9 times 3y, that gives me what? 27 minus 2 equal to 43. At this point, we will apply what we call our additive inverse. When this -2, if you may, students are so used to that method, so I'm trying to be a little diplomatic when handling this part now. We talk about crossing equality sign, but essentially what you are doing is that you are adding the additive inverse to the other side. So that will now be what? 2y, 27y rather, equal to 43 plus 2. Because the additive inverse of a negative is positive, and that will give you 27y equal to 45. And I'll divide both sides by 27, and I'll be left with y equal to what? These numbers are divisible by 9, and I'll be left with what? 5 over 3. You can choose to leave your answer like that, or you change to mixed fraction. But I always advise my students, at this level of learning, nobody's really interested in you changing to mixed numbers as it may. Just keep the answer that way and move on. We are not interested in how, no. This answer will suffice as a final answer to this problem. So that's number 1. Okay, we go to question 2, and this is quite interesting. 1 over 5, a fraction, multiplies x. 1 over 7, another fraction, multiplies x, equaling 7 over 15. So how do you handle a problem like this? Very simple. The first thing you need to do is to express this problem such that you have them in a single fraction. So this would mean x over 5 minus x over 7. Now, lots of questions may begin to pop in, especially if you don't have a strong foundation in maths before this point. This is 1 over 5. Let's do a little recap here. 1 over 5 times what? X over 1. So what's happening now is that this 1, numerator will multiply numerator, and denominator will multiply denominator. So that's how we're getting x over 5. Applying that same idea, you have this, and then equating it to what? 7 over 15. So what do you do at this point? You look for the LCD. As a matter of fact, at grade 10 or SS1, we expect you to be able to, by inspection, get the, what they call the LCD. Now, how do you do that? So I'm going to teach you a quick way to do that, because at grade 10, we don't expect you to begin to rule and do that. No, you have passed that stage. So you should look at the number. I have 5, I have 7. If you look at 5, what's the prime number of 5? It's 5. What's the prime number or prime factor of 7? It's 7. When I come to 15, I'm seeing 2 prime factors. Look at it. When I come to 15, I'm seeing 2 prime factors. I'm seeing 3 times 5. So the LCD or the LCM would be multiply all the prime factors that are unique. So the LCD becomes what? I'm seeing 5, I'm seeing 7. Because I've seen 5 and 5 is still present here, I will now pick 3. So your LCD becomes what? 105. So at this level, you don't need to begin to rule. No. You have passed that stage. You need to outgrow it. And that will be this. So I have 105. Now, when 105 multiplies x, because that's the next objective, the reason you get the LCD is to get a number that can multiply this for a single objective of clearing the denominator. Remember, we said that anytime you're dealing with algebraic fractions, your key objective is to clear the fraction, or rather clear the denominator. We don't want to see the denominator. And how do we do that? We look for the LCD and then use that to multiply. So when I multiply 105 by x over 5, what will be happening will be this 105 will be divided by what? 5. So I'll get what here? 21x. Let me put that here so you see what is happening. 105 times x over 5. 21 times x is number letter. No matter how you multiply, when you multiply a letter by a number, the end objective is always a number letter. So that gives us 21. So that's how we got this 21 here. Minus, I have that 105 times what? X over 7. And that will be equal to what? 15. Now, as a way of added advantage for you, if you have your calculator, you can use your calculator. That would help you to get your job done clearly. But remember that if you cannot think of this step, if you don't have this step well locked, the calculator becomes useless. So you should know where the calculator comes in to help. Calculator essentially is to increase your speed, but a calculator will not do the thinking for you. This thought process should be done. Alright, so you have 21x minus 15x equal to, now you have 7 over 15 times what? 105. And I want to advise you, if you can place this at the side of your work. so that when you're revising it, you remember what you have done to get this work. So you can adjust your work so you write at the middle, and then you keep your solution, your key observations on the left or on your right. Now this will be 15. It may be difficult for you to use 15 to divide, but I want to assume that maybe you're a calculator person. So I know 15 can divide this, and that will be 1. I know 15 can divide this, that will be what? 7. And 7 times 7 will give me what? 49. So this becomes what? 49. So what is 21x minus 15x? That's simply what? 6x, and that will be equal to what? 49. And x will be equal to 49 over 6. You can leave your answer like this. Let me quickly make an observation here, because it's important that while we're doing algebra, you do not forget that what helps you to survive algebra is your arithmetic. Now look at the board. This is an odd number. This is another odd number. In one of my videos, I made this point very clear. If you subtract or add two numbers that are odd, the answer must be even. So if after some you're getting an odd number there, something should tell you that there's something wrong with your answer. It becomes a check for you. So this minus this will give me 6. If I get 5, I should be asking myself, why am I getting 5 there? It's not possible, because I'm actually subtracting two odd numbers. So that clears that, and the answer becomes what? X equal to 49 over 6. Alright. Okay, we go to question 6. We have 2y over 10 plus 3 over 5 equal to 2y over 5 plus 7 over 10. The first task is to look for the LCD. And that will be LCD equal to what? I'm saying 10, I'm saying 5. Look at it. If I divide 10 by 5, what do I get? 2. So that will suggest to me that the LCD for this question will be what? 10. The next thing I do is to multiply each of the members in this equation by 10. If I multiply this by 10, I'll be left with 9y plus, I multiply this by 10. The 10 will cancel out with 5, and I'll have 2. That 2 will multiply 3. So let me write that down to help your work. That will be 3 over 5 times 10. And that will be 2, that will be 6. Equal to what? 2y over 5 times 10. And that will be 4y. So you see, and that will be 4y, and that will be 4y. More like an added note here, you can also look up my I think workbook practice, grade 8 maths, algebraic simplification and I think that should be simplification and expressions. I'm trying to remember what I tagged that is. Simplification and expansions. You can look at that, because I took out time in using New General Mathematics for GSS2 to attend to this idea. The idea we are using here is actually algebraic simplification and expansion. So you may want to go back and look up that video to help you understand this aspect of the work. So that is that, plus I have 7 over 10 times 10. And what does that give me? That will give me 7. So that will be plus 7. The next thing I want to do is to collect like terms. The concept of collecting like terms is very simple. We keep the unknown on the left hand side, we keep the known, that is numbers, on the right hand side. So what do you have? You have 9y. The additive inverse of a positive is a negative. So what I will write on this side will be negative. Equal to what? I have 7. Now 7 is the legal occupant of this place. It has not moved. And now I want to bring in 6. So what do? I will bring in its what? Additive inverse. The inverse of a positive is negative. So that becomes what? Negative 6. And then 5y will be equal to what? 1. The objective here is to ensure that the coefficient of y is 1, because that's what defines the variable. And as such, I'll divide by 5, and y will be equal to 1 over 5. And with that, we are home and dry on that question. Okay, so we go to question 7, and then in question 7, we'll be looking at a new iteration to what we're supposed to do. Now you discover that the numerator is composite. Composite because we have terms. It's more of what we call a binomial. So the denominator, or rather the numerator, is binomial. 2 terms, at least one algebraic thing. So what do we do here? We look for the LCD. It's the same process. The LCD will be 6. Straight up. This one is very straightforward. It's going to be what? 6. So what do you do? Here you have to be very, very careful. Every time you want to go to swim, wisdom demands that you put your leg first and move gradually into the water. Don't, with speed, run into the water to swim. It will not be beneficial to you. If you run in, you may drown. So what's the best approach? You take it gradually. That's what we're going to do now. So what do we do? These 6 will multiply this. So what I'm going to do? See what I'm doing? This 6 will multiply this. This 0 will multiply by what? 6. And what do you have? This will cancel this. And you have what? 2d plus 7 in brackets. I will explain to you why I have not removed the brackets. Plus, this will cancel this. I'll be left with 2. I'll have 2 into what? D minus 5 equal to 0. It's important for you to remember that anytime 0 multiplies a number, it automatically renders that number useless and it becomes 0 straight. There's no controversy about that one. When 0 multiplies a number, it turns into what? 0. So with that said, we now open the brackets. So this will be 2d plus 7. Why is it this way? Because this bracket exists because 1 is multiplying the bracket. 1 multiplying the bracket restores the bracket in its. So we've not written 1 here, but 1 is hidden somehow. So it is 1 multiplying this. That's why this is this. If it's 0, this will turn to 0. If it's 2, this value will not be this. Plus, now, this 2 is affecting the total content of this bracket. And I need us to be very careful because I have math scripts and I see students do wonderful things here. This 2 affects the content of this bracket. So you're going to have something like 2d minus 10. 2 times d, 2d, 2 times 5, 10 equal to 0. The next thing is to, we're talking about collecting like terms, but I have learned over the years studying maths that I don't want to have students who are too mechanical collect like terms. Maths is not like that. So at grade 10, what do we expect of you? We expect you to be able to look at this. If you look at this, what do you have here? 2d. What do you have here is what? 2d. 2d plus 2d. 4d. So I'm teaching my students to add up randomly. You should be able to add up randomly. So what is this here? 7. What is this here? Minus 10. Is that not? The negative is on 10, meaning that my answer will be negative because 10 is big and is carrying negative. So what I do mentally is that I know my answer will be negative. So I would say 10 minus 7. What's the answer? 3. Is that not? So to 3, I add a negative sign to it. This becomes what? Negative 3 equal to what? 0. I don't need 3 on this side of the equation. I need 3 on the other side because that's its true position. The right hand side is the position where we'll keep the numbers or the node. So what happens here will now be what? The additive inverse equal to what? 3. And then I divide those sides to make the coefficient 1. And then it will be equal to what? 3 over 4. And that settles that. So the answer becomes what? 3 over 4. Okay, we'll stop at this point for now. You know, the interesting thing about math is not just about rushing it. Take it little by little and try to see if these little exercises we've had could help you solve more problems. So this is Mamu signing out. Hope to see you very soon.